Hi, my name is Rhys Oxenham, and I'm the Director of the Field Product Management team within the Hybrid Platforms BU. In this video, I'm going to be demonstrating how the poison pill operator can be used to help recover workloads in the event of a node failure, and how it can do so on any OpenShift 4 cluster, regardless of the type of deployment. I'm going to be specifically addressing a challenge that I faced recently with regards to Quay and the way that it stores some persistent data in a Postgres database with a read-write-once persistent volume claim. In the event that the node running this database was lost, we could run into a situation where a surviving node couldn't take responsibility for the database. The reason for this is simple. Just because the cluster can no longer see the node that has failed, it doesn't mean that it's safe to restart the database on another host, and to ensure data consistency, we'll never take that risk. Therefore, we have limitations to what we can achieve with creating a highly available solution for Quay. The poison pill operator provides us with a mechanism to help with a safe recovery, and I'm going to show you how it does this with a real-world example. Here you can see I've got a 6-node cluster, 3 masters, 3 workers. This is a virtualized UPI cluster running on KVM, and it's running OpenShift 4.8.9. If I switch over to the terminal, I've got a watch command on loop that prints out the current statuses of my nodes and lists a list of Quay pods, what their status is, which node they're running on, and the volumes that each pod is using. I've pre-installed Quay, but right now the instance hasn't been configured. Let's head over to the UI and verify it's operational. I'll quickly go ahead and create a new user, and then create an empty repository. There we go, our Quay instance has a basic setup. Let's think about simulating a failure inside of this environment. For our tests, we want to make sure that pods that rely on a storage volume are able to recover, and therefore this Claire Postgres pod is the important one that we want to see recover without any manual intervention. You'll see that it's currently attached to the Postgres data storage volume and is operating on my OCP4-worker3 node. This is the machine that we'll simulate a failure on. We want to make sure that regardless of what happens to this machine, its failure shouldn't impact the running of our workloads for an indefinite amount of time, or require the administrator to take action. Before we do simulate this failure, a few words on the poison pill mechanism and how it works. Poison pill is shipped as an operator and is the default mechanism of remediation as part of the node Healthceck operator, and is currently available in OpenShift as a community operator. It is hoped that this will be officially supported by Red Hat very soon. Installation is of course very simple, like many other operators, and the out-of-the-box configuration gets you up and running in minutes. Poison pill works slightly differently to existing means of remediation in OpenShift, in that it has no external requirements. Many of the other means of remediation require connectivity to external APIs to forcefully reboot suspect nodes. For example, external remediation via MetalCube for bare metal systems. Poison pill recognizes that in the event of a node failure, one of 3 situations is likely to be occurring. Firstly, the node has been abruptly rebooted and will likely rejoin the cluster within a few minutes. Secondly, the machine has become isolated, such as the removal of a networking cable, but is still potentially running workloads. Or thirdly, the machine has been totally lost due to equipment or power failure. Poison pill accounts for all of these scenarios. In the event that one of the 2 latter scenarios happen, where the node is either isolated or has actually been lost, it's safe to recover the workloads that the suspect machine was running, because if the machine was still operating, albeit in isolation, the poison pill is consumed, and the node turns off itself abruptly. And in the event that the machine was actually lost, well, it couldn't possibly have been running anything anyway. Poison pill then permits workloads to be rescheduled onto surviving nodes in the shortest amount of time. Okay, so as we know, our OCP4 worker3 node is running the Postgres database currently, and we're going to simulate a full failure, and we'll just power it off via libvirt. Let's watch what happens via the command line output of the OpenShift API. And please note, this section has been sped up considerably to keep the video as short as possible. For an understanding of the real time frame, see the timestamp top right hand corner. Within 40 seconds or so, Kubernetes will mark this machine as not ready, which is normal practice and gives time for the machine to connect back in if it was just a simple network glitch. After a further 60 seconds, the poison pill operator marks this machine as scheduling disabled, a time period that I have customized via the node Healthceck operator, where the default is 300 seconds, and this represents a threshold in which we determine that we want the poison pill to take action. Scheduling disabled protects us just in case the node does actually come back online, but we know for sure that it is actually down. After a further 3 minutes, poison pill will delete the node. It waits 3 minutes just to be sure that the poison pill was consumed, because remember that other surviving nodes don't actually know exactly what has happened to our failed node, whether it's still running or not. The node deletion frees up any locks that any pods had on any storage claims, and allows new pods to spawn properly and reclaim them. For a time, you'll see that OCP4 Worker 3 is missing from the top node list, but it still has pods assigned to it. This will take a minute or so to clean up, but after a while, replacement pods will be automatically started, or in our case, the Postgres pod rescheduled to another. Here you can see that it is now pending startup on OCP4 Worker 2, a surviving node. Poison pill then automatically recreates the node object for the machine it has deleted, and it does so after 90 seconds. It does this to help with node registration if the machine ever comes back online, even though, as we can see, this machine is definitely still powered off and isn't being automatically registered due to node bootup. After a minute or two, the Postgres database will show us running, and we should be able to access Quay again. We'll immediately see that we have an error message that was generated during our simulated failure. But if we navigate back to the home page by just changing the URL and removing the 500 location page, we're back in, and we have access to the repo we created earlier. At this stage, we can optionally power our third node back on and watch it successfully rejoin the cluster as a fully functioning node. Thanks for watching. I hope that this was useful for you.